Now we're going to talk about the last method for solving systems of linear equations. This is my favorite. This one is elimination. Here are the rules for elimination. There are a couple things that we're allowed to do with equations. We can add and subtract them. We can also multiply any single equation by any number we want. As long as we multiply both sides of the equation by that number, we're fine. Okay, so this first rule comes in handy right away when we're solving this first system of equations, because what you'll notice is if we add these two equations together, that means taking x and adding 2x, that gives us 3x. Then we have positive y plus a negative y, which cancels out. The right side of the equation, 3 plus 0 is 3. We immediately get the equation 3x equals 3, which we can divide by 3 to get x equals 1. Now right off the bat we can tell why this method is called elimination. When we decided to add these two equations together, really it was because we expected in advance that these y variables would cancel each other out. They would eliminate from the equation. That left only an x in the equation and gave us a really simple equation to solve for x. Once we have x, we know that we still need to find y. We can plug that x equals 1 into either equation that we'd like. I'll plug x equals 1 into the first equation, subtract 1 from both sides, and we pretty quickly get that y equals 2. And the solution to the system is the point 1, 2. Let's look at the same second example we had in the last video. In the last video, we did quite a bit of algebra to solve this system. But if we're clever here, we'll notice that if we just subtract these two equations, remember we're allowed to add or subtract equations, that the x terms will be automatically eliminated. 2x minus 2x is 0. 3y minus negative 4y is positive 7y. And 6 minus negative 1 is 7. That very quickly gives us y equals 1, which we can plug into either equation we like. I'll plug it into the first equation again. We're left with 2x plus 3 equals 6. I'll subtract 3 from both sides, divide both sides by 2 now, and we get x equals 3/2. And we pretty quickly get the solution 3/2, 1. Okay, let's do one more example where we have to use both of our elimination tricks. You'll notice here that we can't just add or subtract these two equations to eliminate either of our variables. But what we can do is multiply either of our equations by whatever number we want first. I see two possibilities. One possibility is I might multiply this top equation by 2 to get a 4x here, and then subtract the two equations to eliminate x. The other option I see is to multiply this bottom equation by 3. That would give us a negative 3y here, and we could add the two equations together to eliminate y. There are other options as well, but I'm just going to choose to multiply the second equation by 3. I'm just going to copy down the first equation, and when I multiply the second equation by 3, I get 12x minus 3y equals 12. Now, if I add these two equations together, on the left side we get 14x, the 3y and the negative 3y have eliminated, and on the right we get 13. I'll divide both sides of the equation by 14, and we get x is 13/14. Not the prettiest number. And I tell you what, I really don't want to plug x equals 13/14 back into either one of these equations. So I'm going to make some room over here and I'll tell you what I'm going to do. I'm actually going to multiply this first equation by negative 2 and eliminate x to find y. Our first equation would become negative 4x minus 6y equals negative 2. And I'm going to copy down our second equation. Okay, if we add our two equations together, the x's are eliminated, leaving us only with the y's. We have negative 7y equals 2. And that's going to give us, if we divide by 7, y equals negative 2/7. Okay, that was a much easier way to find y than taking this x equals 13/14 and plugging it back into one of these equations. So I really like elimination quite a lot, actually. And I hope that you like elimination too, because in the next video, we're going to talk about what happens if we have more than 2 equations and 2 unknowns. Say we have 3 equations and we have the unknowns, say x, y, and z. Really, the best way to solve those equations is with elimination. So I hope you like this technique. We'll use it quite a bit in the next video.